Hello Legacy Sabers, Marsh here. So today we're going to look at hyperbolas, which is the next part of our conic section. Very first thing, let's jump in to the parts of a hyperbola graph. So kind of like we had pieces to the ellipse, the hyperbola graphs also have some pieces. So right in the middle, right there is where the center is. Normally you're not going to see the center graphed on a, let's say, a professional graph, or like one you would use on a graphing calculator. The two things that form the hyperbolas, or the two parts of the hyperbola, these things right here, this kind of like a parabola, but they're not. Those are the vertices. So the middle part of the two pieces are your vertices. You're going to have two dots in the middle. Those are going to be our foci, just like what we had for our ellipse. And then those two lines that you see going across, those are what's known as an asymptote. And we'll talk a little bit more about what is an asymptote and what does that mean. So you're going to want to draw this quick little diagram on your notebook for today. The equation of a hyperbola. Normally what this is going to look like. It's going to look like x squared over a squared minus y squared over b squared equals 1. And a, b, and c are related by the equation c squared equals a squared plus b squared. And yes, that is the Pythagorean theorem, and it does work. That's actually how the hyperbola's equation is generated. It's based on a derive of the Pythagorean theorem. Now, what do a, b, and c mean? Kind of like the ellipse had a, b, and c, and we need to find out what it meant. Well, a is the distance from the center to the vertice of your hyperbolas. So off to the side here, I'm going to put a little note. A is vertice to center. Your B value is going to be the vertice to the asymptote up there. So B is going to be vertice to asymptote. And I'll show you why we're going to want that in a little bit. And then your C value is the focus to the center. So same thing, the B value is basically the only difference that from the ellipse to the hyperbola. So this is foci to center. Okay, so let's keep those in mind as we are looking around. Now, there are two kinds of hyperbolas, depending on what the equation looks like. So you can either have a north and south one, or an east and west, depending on what you're thinking, or basically which ones open up and down or left and right. So here's how you're going to see. If the variable comes first, that is going to tell you which way you're going to go. So if it's an x that comes first in the equation, you're going to open left and right, because x is left and right, right? Y is going to be an up and down hyperbolas, pointing up and down. Okay, so that's something to keep in mind. Now, we're talking about asymptotes. Well, asymptotes, what they are linear equations that the graph of the hyperbola will never cross over. Basically, the graph will get closer and closer and closer and closer, but it's never actually going to cross over the asymptote line. Okay, so just think of it as a stopping point. The graph shall not pass that area. Let's take a look and actually draw a hyperbola here. So very first thing I'm going to decide is this going to be a left and right or up and down? So I look here, I see my y is first. So this is going to be an up and down hyperbolas. So I know they are going to look something like this ultimately when I graph. Now my vertices right here tells me this is my A value. This tells me that my hyperbolas or my vertices are going to be 2 away from my center, which is at 0, 0. So I'm going to go up and down. So I'm going to go up 2, put my vertice. I'm going to put a little v by him. And I'm going to go down 2 and put a little v by him. So my two vertices are at 0, 2 and 0, negative 2. My foci, remember, we got the c squared equals a squared plus b squared. So my c, we do not know c, but we do know a. A is 2, right? And then b is this number, square rooted, so that'd be 5. So I got c squared equals 4 plus 25. So c squared equals 29, right? 4 plus 25. So C is the square root of 29. So my foci are a distance of the square root of 29 away from my center. And the square root of 29, quickly on my calculator, is 5.39. So from my center, I'm going to go 5.39 away. So about right there. I'm going to label that with a big nice F. And then about right there, put a big nice F there. So my two foci points are 0, square root of 29, and 0, negative square root of 29. Now, asymptote equations, because they are lines, right? And the B tells us the distance from the vertice to the first point on a asymptote. So I know that my B value is 5, right? So from my vertice, I'm going to count 5 in both directions, from both vertices. So if I go 5 this way, and then 5 this way, then I'm going to do the same thing over here to this vertice. What I have created is the dots for my asymptotes. So now I can go and make some dotted lines going through these dots plus my center. And I'm doing dotted lines because they are asymptotes. They are not actual lines in our graph here. Like that. Now, I need to find the equations of these. Now notice, guys, this does have the same slope, except that they're positive and negative, right? So let's find the slope between these 2 points. So I'm going to go up to 1, 2, over 1, 2, 3, 4, 5. So I know the equation, one of the equations, is 2 over 5x, right? And I'm starting at 0, 0, so my y-intercept is just plus 0. The other one, I go down 2 over 5. So my other equation is a negative 2/5 x. These slopes will always be a positive and a negative. So if you want to write that as a quick way, you could write plus or minus 2/5 x. That would encounter both of these asymptote equations in one equation. That way you get not as much writing. Now you're probably saying, Marsh, we haven't even drawn the hyperbolas in. No, we haven't. But what it's nice, once you get your asymptotes, you're going to take from your vertice and you're going to try to get closer and closer to that line. But you're never actually going to cross it. So you're going to kind of do that. Go on that side and that side. So now I have graphed my two hyperbola and my asymptotes, my foci, and my vertices. Let's try one more. So I got x squared over 9 minus y squared over 36 equals 1. Very first thing, do I have a left or a right? So I'm going to look here. There is an x squared first. So that means I am going to be in a left and right hyperbola. And I'm going to be at 0, 0. This is starting at the origin. My vertices now are going to be 3 away from each other in the left and right direction. So I'm going to have one vertice here, one vertice there. So my vertices are at negative 3, 0 and 3, 0. Let's find our foci. So I'm going to go c squared equals a squared plus b squared. Don't know c, but I do know a is 3, and 3 squared is 9. 36, so 6 squared, 36. Basically, I could take my two denominators in all actuality. So I'm going to get c squared equals 9 plus 36, that's 45. Whoop. If I square up both sides right away. So I'm going to get c equals 3 square roots of 5, right? Because take a 9 and a 5 out and I'll get 3 square roots of 5. And this is approximately about 6.71. Did it quickly on my calculator here. So my two foci from my center are going to be 6.71 away. So kind of close to 7 there. Those are my foci. I'm going to label my vertices here too. See, foci. So my two foci are at 3 square roots of 5, 0, and negative 3 square roots of 5, 0. Now my asymptote, remember to find that, we're going to look at our b value, which is 6, and we're going to go from our vertice up and down 6. So 1, 2, 3, 4, 5, 6. Put a dot there. Same thing on the bottom. Same thing this way. And the same thing this way. So now I get to connect my dots here with a nice dotted dashed line, however you want to call it that. There we go. So now let's find the asymptotes equations. I do know it's going to be y equals plus or minus. Let's find the slope. So I'm going up 1, 2, 3, 4, 5, 6, and over 1, 2, 3. So I am going to have a slope of 6 over 3x. But now, remember, 6 over 3, that simplifies down, right? So actually, my asymptotes have the equations of a positive 2x and a negative 2x. And if you kind of look here, it kind of crosses over. I actually did a pretty dang good job on my asymptote equations. Let's draw in our hyperbolas now. So I'm going to go for my vertice and just kind of slowly get closer to my asymptote as I kind of shoot off into the sides. Like that. Now, what if I give you just some stuff and you need to be able to get me my center, or give me my equation? So very first thing we're going to look at, notice your vertex is at 0, 2. So I know that I'm going to be going on the y, right? Because vertex is at 0, 2. I'm moving on my vertices. So I do know from very first thing that I'm going to be y squared minus x squared equals 1. I just don't know the bottom. I know this needs to be an a squared, and I know this needs to be a b squared. Well, I know my a, because if you think about it, my center is at 0, 0, right? We were told that. And I got a vertex at 0, 2, which is right here. And I got another vertex at 0, negative 2, right? Because you get both pairs. Well, a is the distance of this, which is just 2, right? My distance from 0 to 2 is just 2. So I do know below my y squared is going to be 4, because that is 2 squared. Now, to find our b value, we do know c, because foci, remember c was the distance of the center to the focus, or one of the focuses, which is 4. So I know c squared equals a squared plus b squared. So I do know 4 squared equals 2 squared plus b squared, because a, remember, was 2. So I got 16 equals 4 plus b squared. If we solve for b here, square root, I'm at 2 square roots of 3 equals b. So if I square that, I'm going to get 12, right? So my equation for this hyperbola would be y squared divided by 4 minus x squared divided by 12 equals 1. In all actuality, a graph doesn't really help more. You can just kind of think as you go. I like to use the graph just to be able to see what I'm drawing in ultimately. And I think it does help also to figure out which one goes first, the y squared or the x squared. Let's try another example. So I got foci at 3 square root of 6, or negative 3 square roots of 6, excuse me, and my vertex is at 2, 0. So if I draw my vertex in, so I got one at 2, 0, which means I do have his pair over here at negative 2, 0, and my center's right here. So I do know, guys, that these guys are going to go shooting off into the corners here, because it's going to go away from the center, right? So I do know that I have left and right facing hyperbolas. So I'm going to have an x squared and a y squared first. A is the distance from center to vertex, which is 2. So I do know I'm going to have a 4 underneath the x squared. Let's find what's the b value. So I'm going to have c squared equals a squared plus b squared. C is 3 square roots of 6 squared, 2 squared plus b squared. Because remember, c is the distance from the center to the foci. 3 square roots of 6 squared would be 9 times 6, so 54. Subtract 4. So I get 50 equals b squared. So I can immediately put that 50 below there, because that is my b squared below the y squared. And that's the end of this video. See you later, Sabers.